your normal curve is bell-shaped, and that's still down here. It's still going to be bell-shaped. It's still symmetric. Your mean, median, mode are in the middle. It still happens down here. Your area under the curve is 1. It still happens in your standard normal curve. And as your curve approaches the x-axis, it reaches further and further, but never touches. It still happens here. And we have 2 little inflection points, which we really don't do anything for, these inflection points. As we get into a standard normal, it just defines where the z-scores exist. And we've been looking at that because I make you sketch these things out. So your z-scores are saying, okay, it's coming closer, but not touching 3.49. It's coming closer, but not touching over here, and it still extends way, never touches. But the end of your table, should you be using your table, is at 3.49 and negative 3.49. Your calculator will go on forever and never, but your table won't. So if I say to you, what's the probability that your z-score is less than negative 3.49, if you looked up in your table, you can find me negative 3.49 and nothing else after that. We consider the area to the left approximately 0. Okay, because that's kind of like the end of your table. To the right here, this is approximately 0. So therefore, this area to the left is approximately 100%. Approximately 100% to the left of 3.49. If you're looking at your table, your calculator is far more exact and it can go on forever and ever. But we can't. Cumulative halfway, we say is 50. These are just taking parts of your curve and making it make sense to you. Your area obviously is increasing from 0 to 100 because you're constantly accumulating the area to the left. So that actually makes sense that we're doing this. That's where your percentiles come in. Your ranking comes in. Okay? So those are things we've gone over, and we just added your regular ones to this one. Now, today, this is what we're doing today. We're taking your standard normal curve. This is your standard normal curve. Now notice the difference. We're putting your x values down here now. We're putting your x values, where before these were your z-scores. We're putting your x values here. I do mine differently than the book does. So this is why I like to go over this. I continue to put my z-scores down here. Your book doesn't. I like it better, and always my kids have liked it better, if I put my z-scores here. And if you remember when we got a mean and a standard deviation, I put them up here. Then we added 100 all the way down. So I do mine this way. The book does it the other way. It doesn't matter to me which way you do it. However, if you take a look at this, you kind of lost track of your z-scores. Then you kind of have to write around here that these follow these z-scores. So I keep my z-scores on the x-axis, and I put any x values up on top, just like we've done this before when we hit a mean and a standard deviation. We add, then we go to the left, we subtract. So obviously their standard deviation is 100 here. So then we come here and we subtract all the way down this way. It does two things for us. You see them both at the same time. So if I have an x value of 775, I know it's between 700 and 800, and I know it's between 2 and 3 for my z-scores, closer to my 3. It's okay if you use this, but I just need to let you know I do it that way. I think it makes more sense. The book does it this way, so I took this out of your book. It is the same exact thing. The area under the curve is the same area. The way we separate this is going to be the exact same way. I just find this a little bit more like you lost your z-scores. So I tend to use that method, just so that you know where we're all coming from. Okay, your random variable x is what we're going to be looking for. And we're going to be finding the probability that this happens. This is the way we're going to do the rest of this. We're going to always set up a probability statement. We're going to sketch. We're going to put your mean, your standard deviation out there. We're going to convert your x values to z-scores. We have a z-score formula. This is the one formula that I asked you to remember. That really drives this whole course. We're going to determine if the area is to the left or to the right or to in between. That will be with your words less than, greater than, and then obviously the less than thing for the in-betweens. We're going to find your scores for your scores, and then we're going to look up your areas. Okay, so this is basically the format that we've been using and that we're going to continue to use. So the only difference you're going to see now is we've got x values in there all the time versus z-scores. All right, so let's do one together and see what I'm talking about. A survey indicates that people keep their cell phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. So pull these informations out. You have a mean. That's not very long either. Okay, a cell phone owner is selected at random. Find the probability that the user will keep his or her phone for less than 1 year. This is your probability statement. Right here. Assume that the length of time people keep their phone are normally distributed. It has to tell you that. We're going to see later on there's certain conditions where they don't have to say that, but right now they're going to be telling you that. Normally distributed means I'm using a standard normal curve here. And I have set up like this. Okay, so they're going to tell you this right now. So I start with my probability statement. How do I write my probability statement? But not Z this time. X is my user, is less than 1, right? That my X is less than 1. The X represents my users. So the probability that this person that I selected at random, this is my person, that they held their phone for less than 1 year before they got rid of it, before they traded it in. This is my probability statement. Okay, now I go to my sketch. I put my mean here, and I add 0.25. And I notice I need a 1. It's on the other side of this. Subtract. If you're only on the right-hand side and you just number the right-hand side, that's fine. If you're only on the left-hand side and you just do the left, that's fine. In the beginning, if you just want to number the whole thing and make life easier, that's fine too. So this is where my X values are. Your book is going to put them on the bottom. I put mine along the top. Okay. So now, we look at the X scores and we find 1. And I already can find a Z-score, can I? Because we use this chart. So what is the Z-score associated with an X value of 1? -2. So I'm a little bit skeptical, so I'm going to do my Z-score formula. And I'm going to take my X value minus my mean over my standard deviation. This is going to give me -0.5 over 0.25, and I get -2. It just so happened that one fell perfectly in my graph, didn't it? And I want the time that's less than. So what area do I want? To the left or to the right? To the left. So I'm looking at this. So I look up at my table, the Z-score of -2, and I find my area to my left. So I look up my Z-score of -2, and I find 0.0228. And does that make sense to me? Shouldn't it be pretty small? Right? Isn't 2 a unusual for a z-score? Unusual means it has to be less than 5%. Is that less than 5%? It's actually less than 5% from both sides combined. But they always count it from one side only. I don't know why. So to see what we're looking at, we got a lot of things going on now. And we were doing this. We were actually doing this anyway. But the book is just going through this a little bit different. We're going to set up your probability statement. Now we're looking at the cell phone users, which is our x, our random variable x. We're going to make a sketch. We're going to put your z-scores on the bottom, put your numbers, your x values along the top. Find where the 1 falls. Shade the area for the inequality sign. Find your z-score. This one just happened to fall right there. So I really didn't have to do my z-score formula, but we did just to show you that it's the same thing. Is that making sense? Coming back to you as well? All right, I am a stickler in the beginning about setting things up, about sketching, about setting them up, because no matter how many times I teach this course, I always get somebody that says to me, why do I have to do that if I already know how to do the formula and everything else? And I say, fine. And that's the one person that never gets the z-scores the right way, negatives and positives. If you look at this here, doesn't my z-score have to be negative? Doesn't it tell me subtract the small one minus the large one? There's only two things you can subtract, an x and a mean. If you need it to be negative, subtract the smaller minus the larger. If you need it to be positive, the larger minus the smaller. And you always divide by the standard deviation. So let's have you guys try one. You're going to try this. I want to see sketch, probability statement, probability statement. Joe, you got your probability statement? Okay, X being my person driving. My person driving on this stretch of highway. Okay, so now I fill in my chart. Keep your track of your z-scores. Keep track of your x values. Where do I find 70 between which two z-score values? 0 and 1, very close to the 1. And I want which area, to the right or to the left? To the right. I want it to be greater than. Now, it's close to 1, but I can't use 1. So I pull up my z-score formula. I use my x minus my mean over my standard deviation. And what's my z-score turn out to be? 98571? Wait, 0.85? Thank you. So we're going to round this to 2 decimal positions, because if you use your table, that's what you're looking up. So I said, yeah, it will fall between 0 and 1. Now, when I look this up, my area is less than 50%. I'm sorry, my area is greater than 50%. I want less than 50%. So that tells me right away I have to subtract from 1. So what's your area when you look up 0.86? Anybody look this up? Help.
Is it
1 minus, but I want to know what you found when you looked up 0.86.
It's 0.8051.
Thank you. Okay, so yeah, that showed me it's greater than 80%, 50%, and I knew 84% is at my 1 because I'm close enough to the 50 and then the 34 things. So I subtract this to get my answer. Oops, 1. Okay? And does that make sense? It'll be about 11.5% maybe, a chance that the person that I pulled over was violating their speed limit. All right, tomorrow we'll work more with these.